What up, mathematicians? It's your boy Kennedy here with another math class. This is 20-1. We're talking lesson 4.3. That's unit 4, lesson 3. We're going to solve some systems of equations. But before we get to that, make sure you go hit the like and subscribe button. If you hit the little bell, you'll get a notification. You'll see every time there's an exciting math video for you to watch. All right, let's start solving. Oh, and if you don't do that, you'll get bad luck for like 1,600 million years, I heard. Okay, let's get at it. So, systems of equations. We've got 2 lessons down. Both were algebraic lessons. So, our first lesson was solving a system of equations with substitution. The second was solving systems of equations with elimination. Today, we are going to solve systems of equations by graphing. Cool. Graphing is honestly one of the better or easier ways to do things. The only trick to graphing, let's slide it down here, is that you have to have an equation where you isolate y. So graphing only works if it's y equals. You can't graph if you have something else. So if we jump right down to this first example, we've got what is the solution to this system of equations? And if you look at your equations, this is not y equals. All right, so we're going to have to do a little bit of manipulating of that equation in order for us to actually graph it. We're going to have to get that y by itself. To get that graph by itself, or that y by itself, I'm going to subtract 5x from both sides of the equation. So I now have y equals 2 minus 5x. If we look at our second equation, we got the same problem. That is not y equals. So I need to move that x over by subtracting 1x to the other side. This is a little bit of a tricky one because that's a negative y, and the negative is still there. Now that does not count as y being by itself. That's negative y. We want y. So we have to get rid of that negative symbol. What that negative is it's really a negative 1, right? So that's really negative 1 times y. So what we need to do is divide that negative 1 to the other side of our equation, giving us y equals negative 4 plus x. Fantastic. And now I have my 2 equations here. I have y equals 2 minus x, or 2 minus 5x, and I have y equals negative 4 plus x. What we're going to do is we're going to try to graph this to make it fit. So go ahead, throw that into your graphing calculator under your y equals button in the top left-hand corner. First one is going to be 2 minus 5x. Second one is going to be negative 4 plus x. So y1 and y2. You see you have many options for your y equals. Then you're going to pop over to your window, and we're just going to set the window to be the same as this window over here. So if you look at our little graph on our piece of paper, our windows are already set up. We have an x minimum of negative 1, negative 2, negative 3, negative 4. So that's negative 4 as our x minimum. Our x maximum is positive 6. The x scale is 1. That means it's counting up by ones. My y minimum, so that's the lowest the graph goes. It looks like it goes down to negative 5 here. My y maximum, if I look at my graph, it looks like it goes up to positive 5. And the y scale is just counting by ones. Once you have put those into your y equals, you've set the proper window. If you hit graph, you should get 2 equations. One of them, I'll try to do them color-coded here so you can see. Oh no, how do I do this? There we go. The first one, 2 minus 5x, should look something like this. When you graphed it, you should have got that purple line. When you graph the second equation, you should have got this line. to give you your two equations. Now remember, we're solving a system. So solving means you're finding where these two lines cross each other. In this case, it's pretty obvious when you're looking at it that they cross right here. Oop, that is not going to work. Let's try that again. They cross right here. Right? So that right there, that point is going to be my solution. Now it looks like it's perfectly at 1 comma negative 3, but sometimes there's decimals there. So you might have to use your calculator to find the exact value. The way you do that is on your calculator. You hit the second key. Well, let's not choose bright yellow. That's not very good. No wonder you people don't just subscribe to my channel using colors like bright yellow. Hit the second key. Hit the trace key. So you hit second trace. You're going to get a whole list of options. The option you want is the fifth option. It's called intersect. And when you hit that, it's going to take you back to your graph. And on the bottom of your graph right now, it's going to say like first curve. So you'll notice your cursor is on your first line. It's blinking probably at you. If you use your left and right arrows, you just move your left and right arrows to where your intersection is. So move your left and right arrows right here where this yellow spot is. When you're close to that, hit enter. Then it's going to say second curve, hit enter again. Then it's going to say guess, hit enter again. And it will tell you exactly where that answer is. That answer is 1 comma negative 3. Again, with the bright yellow, that's called not learning from your mistakes. Fool me once, shame on you. Fool me twice, shame on me. The correct answer is 1 comma negative 3. And that's all it is to graphing. It's nice and easy. So you're just going to literally get it into y equals, graph both things, second trace intersect, pretty much hit enter 3 times, and you're good to go. I want you to try a couple here. So there's these two here. Don't worry about doing the extension question. When we do in-person learning, we'll do the extension question. With online learning, if you're just watching this video at home, don't worry about it. It's not ever going to be tested. It's just kind of a neat concept to talk about. We don't need to stress it right now. So go ahead and do these 2 examples up here. Pause the video. Try your best. Okay, so if you graph these 2 things, the trickiest part usually on graphing questions is the window. When you don't know anything about the window, I just usually go with minimums of negative 10. And maximums of positive 10. That's called our standard window. And that usually gives me enough of a glimpse that I can then figure things out. If we graph these, this first one, when you graph it, should turn into something like this. And the second one, when you graph it, should turn into something like this. Oof. It's pretty close. I wish it was a little bit more closer to there. Yeah, we'll go with that. Either way, you should get 2 quadratics, one facing up, one facing down. This quadratic function, this linear equation. Whoa. What am I? I'm just saying words. I'm just saying math words. This system of equations has 2 solutions. One right there. And another one right there. That means you're going to have to do second trace intersect twice. The first time, second trace intersect, and you're going to use your left arrows to move your little cursor close to this first dot, the one on my left. Then you're going to hit enter, 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 and that's going to give you an answer of negative 0.86, comma, negative 4.9, 0.49. Then you have to redo it. So your calculator can only find one intersection point at a time. So redo it, second trace intersect. Move your cursor to the right, hit enter, enter, enter on that right dot, and you get 0.46, comma 0.57. And you got your two answers. Easy peasy. Second equation, if you graph that thing, this first one should look like this. Ooh, that's tilted a bit to the right. And the second equation, if you graph it, should look something like this, I think. Let me double check this. So in your y equals, you have negative x squared plus 4. Make sure you have a negative, not a minus. So the negative is beside the decimal. And then in your y2, you have x plus 5. You graph that, and you have exactly what I drew, almost to a T. It's like your math teacher's an artist. You guys are so blessed. Blessed up. Just, that was terrible. I can't edit that out. Like, I'm ashamed I said it. Let's move past it. So we got those two equations, y equals negative x squared plus 4, y equals x plus 5. When you look at that, you notice that there's no intersection point. Right? They never cross each other. That means this is a situation that has no solutions. It is what it is. They do not cross each other. There's no point where they would have the same x and same y at the same time. Wouldn't happen. Fantastic. We are going to do a couple sample questions that are standard of excellence. Remember, that's like the top 20% challenging type of question. So it's an extra hard question. This first one says solve the following system, round your solution to the nearest tenth. Now, I could look and I could probably estimate my answers, right? Like it's in here. There's one answer. I could probably estimate it, and there's another answer, and I could estimate it as well. But our goal is not to estimate. We want to actually find what those equations are and what those points are. So what we need to do is we need to build these equations. We need to take each one of those lines and turn them into an equation so we could graph that equation on our calculator, and then we can do second trace intersect on our calculator and know exactly where those two solutions are. Let's start off by finding this quadratic function. So the quadratic function is this one in red. Ooh. Let's find that guy. Okay, we did lots of this in unit. Oh, it's throwback with Thursday. I don't know what day you're watching this video. It's actually Wednesday when I'm making it, but that's just history. It's Tuesday today. Anyways, okay, let's make this quadratic. So that red line. This is a throwback to unit 3, making quadratic equations. You have two options here, right? You can choose either vertex form or factored form to create. I'm going to choose factored form. If I look at this, I can clearly tell that this has two x-intercepts right here and right here. We call those m and we call those n. So that's going to start us off. Our factored form looks like this, x minus m, x minus n. You also could have made vertex form if you wanted. M was -2, so we have minus -2. And n was +2. If we do a little bit of simplifying, that means I have x plus 2, x minus 2. Now, we've almost got the quadratic built, except to build this quadratic properly, you have to solve for this a value, right? You have to have a number there. The way we solve for that is by using a random point on the graph. I'm going to use the vertex as my random point. That point is at 0, -4. That'll be my x, that'll be my y. So if I go back to my equation, I change y to be -4 and x to be 0. That leaves me with -4 equals a x plus 2, or 0 plus 2, 0 minus 2, like that. This allows us to do a little bit of calculations. So that means I have negative 4 equals a. 0 plus 2 is 2. 0 minus 2 is negative 2. That means I have negative 4 equals a times negative 4. Notice that I still have it in brackets, right? 2 times negative 2 is negative 4. That is not a minus 4. That's a times negative 4. My last step is going to be to divide that to the other side. So if I divide both sides by negative 4, I get 1 equals a, giving me my first equation, y equals 1 times x plus 2 times x minus 2. That is our quadratic function. What's funny is that quadratic is a lot harder to build, except you guys do well at it because it's from this year and it's fresh in our brain. The linear equation that we're about to build, this blue one, is actually a lot easier, but we forget how to do it because it's been a year that you did this in Math 10C. To build a linear equation, you need to know the format in which you build it. Much like in that quadratic, we started off with factored form, linears have a form too. Linear form looks like this: y equals mx plus b. And now you might be thinking to yourself like, oh yeah, I remember this. Where m is called the slope of a line, and b is your y-intercept of that line. So we have to find those two values. We've got to find m and b, and then we would have a linear equation. Let's start off with trying to find m, the slope. To find the slope, what you do is you take 2 points on your graph. You can be anywhere on the graph. Okay, so if I look like that, looks like a perfect point to me, and that looks like another perfect point to me. If you notice, there's actually a lot of points you could pick. You could have picked here, you could have picked here, you could have picked here. You could pick any of these points along the line that I've circled in green. Just pick 2 that are closest together. Again, I'm going to pick those 2. Just randomly, that's the 2 I chose. To calculate the slope, you were then going to figure out, moving left to right, what the rise divided by the run is. Rise is how high up you have to go to get to the next point. The run is how far to the side you have to move to get to the next one. So in this case, I have to rise 1, 2. I have to rise 2, and I have to run 1. That means my slope for this question is 2 over 1, which is just 2. If I was to go down, my rise would be negative. Notice that I'm always going to go to the right, though, so that my run is always positive. Perfect. So we've got our m value. To get our y-intercept, we just look at this graph. We look, there's my y-intercept right there. That's called my b value. It's at negative 3. I can now create this equation. My equation is y equals 2x minus 3. 2 is the slope, because I rise 2 and run 1. Negative 3 is the y-intercept, so that negative 3 just goes there. And the b value. Now you have 2 equations. Now using your calculator, you can graph these 2 equations into your y1 and y2. You can then do second trace intersect to figure out where those things intersect each other. It says round to the nearest 10th, so we're going to do exactly that. I'm just going to throw this on my calculator quick. We already kind of could estimate what our answer is going to be, but this will give us a better solution. So second trace intersect. The first answer I got was at negative 0.41, comma, negative 3.8. Oh, it said round to the nearest 10th, didn't it? Yeah, nearest 10th. So negative 0.4, comma, negative 3.8. The second solution, you go second trace intersect in your calculator. You hit enter, enter, enter. Make sure you're doing it over by the other solution. So you have to use your right arrow to move your cursor close to the answer. You get 2.4, comma, 1.8. And those are my two solutions. You are 100% going to get a question like that, where you will have to build the equations and then find the true intersection points without just estimating. You're getting marked on your work, right? So make sure that you're not just guessing, because you could look at that question and guess, right? But you're getting grades and marks for the work of building the equations. All right, last question. I'm going to give you a minute. Go ahead and try to graph those two functions right there. Use your standard window. I think that should work fine. So graph it and then make sure it's the same graph as mine. You should have two graphs. I'll do this one as the blue one. One that looks like this. And it's quite skinny. And then you should have one that's a little bit wider. Like that. Holy, Picasso over here. That's like spot on. You think I got some serious like quadratic parabola like cheating functions on my computer? That's so good. All right. Write the coordinates of the intersection point. So if you did second trace on those two equations, move left or right, you're going to get two answers. It's going to be at 2, 2. That's one answer. And the other one I think is going to be negative 2, 2. But let's just ensure we are correct using our calculator. Second trace intersect. Yeah, look at that, negative 2, 2. Okay, now that's all kind of like basic, right? This last part is the trick. So how could you transform one of the graphs so the graphs do not intersect? Write the equation of the transformed image. I want you to pause the video, think about it for a second, say, how could I transform, that means move, how could I move one of those graphs so that there's no intersection points? So think about it for a minute, see if you can get a solution to that problem. Awesome. There's infinite solutions here, right? So if this was a multiple choice, obviously there'd only be one right option. But if this was written response, there's actually a lot of correct answers. The most common answers that I get is that you could change the y-intercepts of those values. So if you look at that blue one, for instance, if I was able to take that blue equation and just shift it upwards so that it was like this, that would no longer have any intersection points. And the way you could transform it upwards is by changing the y-intercept, which is our constant value right there. So if I wanted, I could change that equation to be 2x squared, and let's say plus 5. I know plus 5 would work because the other y-intercept is at plus 4. So my y-intercept just needs to be above the red y-intercept, and I would have no solutions. So that's one answer that you could have. Transform the first graph to become plus 5. Leave the other one the exact way that you see it, like that. You could also move the red y-intercept down. So you can move it the other way. You could take that y-intercept, say, well, what if I shifted this down so it looked like this? That would work too. So another possible solution would be just to make the y-intercept on the red one really small. The blue one originally was at negative 6. If I change this y1 to be, say, negative 10, I'm just picking a number that's less, that would shift my red graph down so that there's no longer any intersection points. I'm just going to talk about a couple other options. So a couple other options is you could shift these graphs left or right. If you shift this red graph far enough to the right, it eventually would look like this. And you notice it wouldn't be touching the blue graph anymore. You could also shift it to the left until it's like that, and you notice those graphs would never touch each other, the red and the blue. You could also do the same thing with the blue one, shift it left or right. That would work as well. In order to shift it in your equation, you would have to have those in vertex form and change the p value, right? The p moves things left or right. The last one that's the trickiest one is if you look, the blue graph is definitely skinnier than the red graph. So what that means is it means I could flip that graph. And if I flipped that blue graph so it was upside down, and then if I moved it so it was underneath the red one, like that, those two graphs would then never cross each other because the red one is getting wider while the blue one is skinnier. So it would actually be like inside of it, right? And then it would never touch. You could also do the same thing the other way. You could flip the red graph so that it now faces up. And then you could leave the blue graph inside of it, like that. And those also would have no intersection points. To flip a graph, remember you change the a value, so that's the number in front of x squared. So to flip it, you make the a value either positive or negative, the opposite of whatever it is. Right? Negative would go down, positive would go up. Cool. That's more just like a thinking question. Like, what could you do to these graphs to get it so that you have 0 solutions or 1 solution or 2 or whatever you need? That is the end of solving systems of equations. All you guys have left is some word problems, and then you're done basically the full first half of this unit, which is fantastic news for you. And then the second half of this unit is going to be like a whole different topic. It's kind of like 2 mini units combined into one big unit. Take care of yourselves. Make sure you do something that you enjoy today, something that makes you happy. Talk to a friend, talk to somebody out there in the world. Just do something that makes you happy. You guys deserve it. Take care. Bye-bye.